Hi, I'm Huang Ziting. Today I'm going to talk about current situation and future development of TSMC. This is the list of our contents. To begin with, I will introduce TSMC. Second, my partner Wei Chen, Peilin, Yanxun will explain the impact caused by COVID-19 and the challenges of TSMC. Third, my partner Qi Shuo will talk about the future prospect of TSMC. Finally, I will conclude our presentation. Before I start, does anyone know how much money TSMC makes for Taiwan each year? According to a line graph, from 2012 to 2020, its revenue has gone up for about 10 consecutive years. In 2020, the revenue of TSMC has even more than 1 trillion. Based on its annual revenue, we can know that it is one of Taiwan's largest companies and the world's most valuable semiconductor company. And TSMC is a company which manufactures wafers. The wafers is the piece of semiconductor material, and after being processed, it becomes a chip. And next, welcome my partner Wei Chen. He will explain the impact of COVID-19 on TSMC.
TSMC is the world leader in high-tech chip production. Basically, more than half of the chips all around the world are produced in Taiwan, and even about 90% of the most high-end chips are produced by TSMC. We can see this in the next two figures. And this is the market share of foundries of various companies. As I mentioned above, more than half of the chips are produced in Taiwan. And in this figure, we can clearly see that the most high-end chips, like 10 nanometers to 5 nanometers chips, are mostly produced by TSMC. And by the way, the most high-end chips are usually used to supply electric vehicles or military weapons. The founder of TSMC, Zhang Zhongmo, pointed out at a press conference. He said that COVID-19 had accelerated the global digital transformation. For example, the rise of electric vehicle industry. And in addition, semiconductor chips are not only related to our daily necessities, such as mobile phones or computers, but are also closely cooperating with the development of military weapons. It could be seen that semiconductor chips are required everywhere, and COVID-19 had drastically become more important. However, due to the proper control of COVID-19, domestic chip production in Taiwan has not been affected over a year, but has even accelerated. And therefore, the European Union, which lags behind Asia and the United States in semiconductor industry, also graciously invited TSMC to set up factories after they suffering a chip shortage. Even the German government, which always keep the distance from Taiwan in politics, was seeking help for chips from Taiwan to support their auto industry that they were in trouble. And at that time, Taiwan was also lack of vaccines, So there was the possibility of chips for vaccines. And TSMC also confirmed that it will build a chip factory in Arizona, which will be the first time in 20 years for TSMC to build a chip factory in the United States. Therefore, it can be seen that Taiwan is gradually interacting with other countries, with the world, and through the chips, interacting with the world through the chips. And there are more and more means and discourse power for Taiwan to negotiate with other countries. Which also symbolize that Taiwan symbolize the significant improvement of Taiwan, significant improvement of international status of Taiwan. Yeah, this is my presentation. And welcome my next partner, Pei-Ling. She will introduce the challenges that TSMC will face.
In addition to solve the problem caused by COVID-19, TSMC also has many existing challenges to overcome. First, silicon continues to mushroom at every level of industry. Hiring and retaining top talent is big business. Lack of talent is currently a common problem faced by Taiwan's high-tech industry. In recent years, China, South Korea, and other countries have increased their semiconductor research funding to hire outstanding talent from other countries. As illustrated by this slide graph, it can be seen from this chart that TSMC has also been very active in hiring with national talents in recent years. In addition, integrating with university and retaining domestic talents is also one of the talent cultivation programs that TSMC is currently actively carrying out. They launched a semiconductor program with National Tsinghua University and had attracted more than 200 students to enroll. On the government side, in order to solve the problem of talent shortage in companies, the exclusive U.S. passed relative bill, not only to relax working conditions, but also to relax the application period for permanent residents to 3 years, hoping to attract more overseas experts come to Taiwan. Another challenge for TSMC is competition from all over the world. In recent years, China's rapid rise has made many countries feel threatened, including the United States. In March, the Biden administration launched the American Jobs Plan, which has a budget of $50 billion that will go straight to the semiconductor sector. They also reached out to the companies worldwide, asking for resolving the chip shortage and fighting the dominance of the supply chain. In addition, Intel CEO also said that it is not safe practice for the semiconductor industry to have most of the supply chain in Asia, after the US-China trade war and the outbreak of COVID-19. It also indicated that it will increase investment in setting up factories in Europe and the United States. How to respond to this change in the international situation will be the major challenge for TSMC. Next will come my partner Yanxun. He will introduce two other difficulties faced by TSMC.
Hello everyone, I'm Yanxun. In addition to the parts mentioned above, sufficient pure water is the crucial part to increase the yield of wafer manufacturing. In the process of making wafers, the parts must be rinsed with pure water to ensure that there is no molecular residues on the parts. However, the report points out that TSMC needs 165 1,000 tons of water per day, accounting for 1% of water consumption in Taiwan. And the 2 nanometer wafer manufacturing plant planned in 2025 will double the water consumption. Ensuring sufficient water resources is the priority. For example, the recent drought in Taiwan has caused TSMC to try to use nurse tankers to supply water for the factory. Actually, 8,000 nurse tankers filled with 20 metric tons of water are required for a day. It is unwise to use nurse tankers to transport water. On the other hand, TSMC is advancing the technology of recycling sewage. The current recycling rate can reach 86%. According to the data provided by TSMC, a drop of water can be reused 3.5 times. But the purity of water is not enough, and it can only be used as water for people's livelihood. The Nanliao desalination plant in Hsinchu, built in February this year, is also a solution to water shortage. It can provide 10,000 tons of water a day, even though it needs a lot of electricity. Building more desalination plants is the most practical and feasible approach. According to Taiwan's Minister of Economy, the desalination plant will be built in Hsinchu, Jiayi, Taoyuan, Tainan, and Kaohsiung before 2031, ensuring the power and water supply will be our challenge.
This chart is Moore's law, which is an observation and projection of a historical trend. And this is only a schematic diagram, so just ignore the words beside the dots. Moore's prediction has been used in the semiconductor industry to guide long-term planning and to get targets for research and development, thus functioning to some extent as a self-fulfilling prophecy. However, some experts indicate that the physical limits to transistor scaling have been reached due to source-to-drain leakage, limited gate metals, and limited options for channel material. In other words, Moore's law is dying. Does this trend mean that TSMC will lose its advantage in the coming future? I don't think so. In my opinion, we can try to change the material to extend Moore's law. For example, carbon nanotube transistor is a material that is 5 times more efficient than silicon transistor, although it has some weakness such as short circuit. Another example is graphene, which has been seen as a miracle material because its characteristic can be applied in a variety of fields. But it still has a long way to really be applied in semiconductor domain since its structure is not stable enough. Gallium nitride and silicon carbide transistors are the most popular semiconductor materials. since it's high efficient. This chart is a prediction of gallium nitride and silicon carbide application. Different colors represent application in different fields. No matter military and aerospace, hybrid and electric vehicles, and so on, they all have a growing trend from 2018 to 2020, and it is supposed to keep growing in the following 10 years. To sum up, physics limit will never be the excuse for TSMC to stop moving forward. In contrast, just like what Morris Strong, the founder of TSMC, used every cloud has a silver lining to describe the condition of development of semiconductor. TSMC would always find the way to stay at the peak of semiconductor field.
Let's summarize briefly what we have looked at. Because of the proper control of COVID-19 pandemic, chips production in Taiwan has not been affected over the year and become more important in the world. Taiwan may exchange chips for vaccines. However, its lack of talent, competition from all over the world, and the need of a large quantity of waters have set difficult challenge for TSMC. Although someone may say TSMC will lose its advantage in the coming future, we think there are many ways to keep TSMC staying at the peak of semiconductor field. This brings me to the end of our presentation. Thanks for your attention.